Aiden, Jason, and Max. And I will talk about the app in a little bit, but first I wanted to do just a little bit of housekeeping because we are actually approaching the end. If I pull up my calendar here, so we're here on the 22nd, which by coincidence also happens to be the first day of the World Series. And in 2 weeks and change, on November 7th, that's our last day of class. So we have 1, 2, 3, 4, 5 more nights of lecture. And then the last day of class, which is Thursday, November 7th, is going to be presentation of final projects. So we did this halfway through at the 5-week mark. And we'll do it again on the last night of class. And this is basically your demonstration of what you've learned in the course of this Python class. And the intention is on that last night that you will put together an app, a dashboard in Plotly. You'll deploy it on Heroku. It will demonstrate a lot of the things that we've learned in this class, primarily the ability to visualize data, to run a callback, and to use a pandas data frame. Those are the 3 big things that GA is looking for in your app. And that you'll come up here and you'll spend about 7 minutes talking us through what you did and why it's cool. And we'll spend the entire evening on that. GA will provide, typically they have falafel and a selection of beers. And the whole class will be just individuals coming up and giving their presentation, kind of similar to what we did at the halfway mark, but a little bit more in depth. So that is 2 weeks away, and like I said, 5 lectures away. You guys have any thoughts or questions about that? Or any lack of clarity about kind of what the expectations are on that? Yeah.
I'm pretty lost with callbacks.
Okay.
I slept through that lecture. I need to review stuff personally, but I guess I can just work on my own on just like reviewing class notes and reviewing other sites and other resources. But besides copying someone else's callback or code, I'm pretty involved.
Having trouble with that? Okay.
Yeah.
So Thursday's class, not tonight, but Thursday, the whole thing is intended to be Plotly, just 2 hours of Plotly.
Okay.
So I will hit callbacks hard and heavy in that section, and hopefully that'll answer any questions that you have.
Great.
But in addition, I do think that it is useful to go back and look at the examples that you've gotten from me or from others in order to kind of refresh how that works.
Should we be able to like develop our own callbacks from scratch that do all this crazy stuff? Because besides copying people's callbacks, I'm lost.
Well, in an ideal world, yeah. We would like you to reach a point where you are in fact able to develop your own callbacks from scratch with minimal looking at other people's code. But in the meantime, if recycling code and making appropriate tweaks works, it's not a bad place to be by any stretch. Especially because I honestly haven't spent a lot of time on it. What I've done is I presented you silent examples and had you kind of figure it out on your own. So it totally makes sense that you are where you are.
I had to do some more figuring.
Yeah, but Thursday night, all callbacks all the time, okay? Other questions about Thursday, November 7th? Okay. Second question. Next week, the 29th and the 31st, which is Halloween, which happens to be Halloween, that's not important. If possible, it would be really helpful to me to get out of here by 8 o'clock because I actually have another commitment and taking an online webinar for AWS that starts at 9 o'clock p.m. So would you guys be okay, or would it be possible to start class at 6 p.m. and end at 8 instead of 6:30 to 8:30? And you don't have to tell me right now, but you can give me like direct feedback on Slack if that would be problematic. Showing up at 6 and leaving at 8 instead of 6:30 to 8:30. The other possibility is that what we just did this first 30 minutes, that I do that outside of class as sort of a homework assignment, and that we start at 6:30 but still end at 8. That also would be absolutely okay. And that I just start the lecture directly at 6:30. But either way, if there's a way that we can accommodate me getting out of here by 8 or 8:10 at the latest, it would be super helpful. So go again, you don't have to answer now, but if you can send me a note on Slack saying, hey, Austin, I really want to be here until 8:30 or whatever, or I can't get here at 6 because, I'm at work. that would be helpful feedback, okay? Cool. But yeah, Thursday, November 7th will be final presentations, so do have that on your radar. And you can go ahead and build on what you did at the 5-week mark, or if you want to start something completely fresh, you do want to keep an eye out for a simple data frame or data set of some sort. Don't shoot the moon. Don't feel like you have to merge in like 10 different data sets that you got from NASA. Just choose something simple that's easy to get from Kaggle or someplace like that, because the idea is that we would just want to see you be able to demonstrate your knowledge of pandas, of Plotly, and of callbacks in particular, okay? Cool. All right, well, on that note, let's go ahead and take a look at tonight's app. The original was DC Housing, and those of you who were able to submit, you were able to change it to DC Crime. This one doesn't have any callbacks. It's just a simple visualization, but it's a little different from a couple of the maps we've seen previously. Number one, because it is a choropleth map, that is to say, one that you can zoom in on, right? Like if you really wanted to navigate from here to your house, you genuinely could do it with this map, right? Or frankly, all the way to Greenland. It zooms all the way out. Which, when we did the previous map, which was the Iowa corn app that showed agriculture in the United States, that's a shapefile map. It's not a choropleth map. But this one, it's got open streets as its base layer. And so it allows you to superimpose your data on top of an open streets map, which is it's a nice functionality to have. Specifically, this is a heat map. The original is about volcanoes, but I updated it to show DC houses and DC crime. And I was really excited to see that a couple of you guys actually had some kind of a, as Max has here, a slider, or Megan has the drop down that makes the map just that much more interactive. So that's absolutely fantastic. Let's take a look at app.py and see what it's got going on. Okay, so here's the original app.py. It has a few imports that aren't actually needed. If you haven't picked up on this yet, I actually just copy and paste my imports from one to the next, and sometimes I need them and sometimes I don't. Pickle is not used in this one at all. Neither is state, for that matter. Frankly, almost none of these are used, but the rest are. So up here at line 15, we read in the data frame, which is in the resources folder, and then dcproperties.csv. It's just a pandas read CSV. And then at line 17, I apply a filter. And as the comment mentions, the reason for this filter is what Jason ran into, which is the data file is really very large and it takes a long time to deploy and a long time to load. So by restricting it to only those houses between 300 and 500 grand, it makes the data load that much faster. Another way to do this would have been to do like a sampling, or to have restricted it to a certain property type. Any of those can certainly make things load faster. And then there's not a whole lot of code that goes into the figure, but it is definitely a new set of code. We've seen go.figure before, and in the past, go.figure has been a combination of data plus layout. This time, go.figure is loading a different Go method, which is density mapbox. So Mapbox is actually a startup located over on 15th Street that provides mapping data that underlines really a very large number of apps and open source products that are available on the web. They're known for the accuracy of their maps, but above all, kind of the visual impact of their maps. They do some really stunning graphic art with their map styles, and you can choose from a wide variety of Mapbox map styles. And at some point about 2 years ago, Plotly and Mapbox came to an agreement to work together. So Mapbox has kind of out-of-the-box functionality to deploy Plotly, and Plotly has some methods that are built into the Dash ecosystem to call Mapbox as their map style of choice. It's not the only style of map. You can use other Python mapping libraries. A very popular one is called Folium, for example, and there are a couple of others, and you can even call OpenStreetMaps directly. But for the simplest kind of out-of-the-box functionality, they have a number of Mapbox styles. And I believe in the GitHub repository, I actually have a link to the Plotly documentation about how to deploy Mapbox if you'd like to go a little deeper on that one. I'll do another one on Thursday so you can have a second example of using Mapbox. But this particular Mapbox is a density map. And it's a density map because it gives you that kind of heat map feel of where there's a lot of points, they get clustered together into a sort of blended yellow amorphous shape, which is different from the scatter Mapbox style, which is a very clearly delineated point for each one of the elements in your data frame. But once you've called the density Mapbox method, it really has some pretty simple parameters. It asks for a latitude, a longitude, and then a z variable for coloration or density purposes. So latitude and longitude obviously have to be those two things. It has to be a column in your data set that represents latitude and a column in your data set that represents longitude. And there's obviously lots of such data sets available out there. I gave you two. But the third variable, which in my case happens to be price, this needs to be some numeric variable because the purpose of the z parameter is to provide the density around which each one of the points is clustered. So if it's not numeric, if it's categorical, that's not going to work. And then radius equal to 10 simply shows the radius of each one of the individual dots. You really start to see some significant changes when you get up to around 50 or so. And if you put it all the way down to 1, then it gets so fine-grained that probably almost nothing will appear on your map. But 10 is kind of a nice sweet spot. Mapbox has a number of styles that are available. I'm actually not an expert on this. I just have a couple that I can use kind of out of my own toolkit. But Stamen Terrain is the one that we are seeing here, which is this shows green space and slight indication of elevation, like here around Arlington Cemetery, for example. You can see that there's terrain going on if you don't zoom in too much. That's what the Stamen Terrain style is doing. And it has a couple of others that you can choose. That's simply the background map upon which your data points are going to be mapped. A couple of additional parameters. These are not necessary, but they're super helpful. If you were to comment these out, lines 23 through 25, you would get a map of the entire world centered somewhere, I think, on the Eastern Pacific. So by choosing the center longitude, center latitude, and zoom, you have a center spot in the world, and then you zoom into that level. 1 is the farthest out, and I believe 15 is the farthest in. So by choosing 11, we roughly get, DC shows up. So that's what these 3 lines of code are doing. And then the margin, again, this is simply optional, but this gives slight, or it can allow you to give slight padding. I've chosen it to be 0 at R for right, L for left, T for top, and B for bottom. It just gives you a little bit of padding around your map, and this is especially helpful if you plan to embed your map in an app that has a lot of other text or functionality around it. These are pixels, obviously. So once you've defined your figure, the rest is pretty straightforward. We've got a heading, we've got the graph, which is calling figure 1. Sorry, the ID is figure 1, and rather it's calling the figure fig that was defined up in line 21 using the scatter mapbox element. And then the rest is pretty straightforward. So everything lines 31 through 39 should be familiar to you from what we've seen in the past. And debug equals true in line 44 makes it so that if you save your app, it will automatically refresh if you've got it running in terminal. You don't have to close out and log back in. Okay, so questions about this app?
How do you change the shape of the map display? Like right now, it's very like long.
So right now it's very rectangular, right?
Yeah.
And if I make this full screen,
Oh, does it just go to the? Oh,
so what it's doing is it's
it's
resizing. That's a great question, but it's resizing.
That's the question we can't define.
Yes. But the way to do that is something that we've seen in the past, which is to use the columns element. You know, you can break it up into 12 columns. So if I were to display this as style equal to 6 columns, then it would only fill up half my browser. And that would, I think, would be the best way to style it. Other questions?
How do you change the colors of the scale? Is that the...
Oh yeah, excellent question. This one is, I think this is jet or plasma, which is a default. So I'm going to break this up so it's a little bit more obvious that we're working with parameters of scatter map box. And then go.figure. I believe it would be here because this is how it is with other scatter plots. It would be color scale is equal to, say, viridis. Let me try this. I'm pretty sure this will work. I'm going to save. I'm going to run. And if this doesn't work, I have another example that will demonstrate it. So it doesn't like that one. It doesn't like that color scale. If I drop it inside, does that make a difference? All right, let me see if this deploys properly. 127. There we go. Yep, that definitely did. So you see how now the color scale has changed to viridis? And then one more example just to make it really simple. Instead of viridis, if I simply did reds, reds is a scale from light red to dark red, and I save, and I deploy, refresh, and there it goes. Okay. So what I did was I added that inside of the density map box option. And if you want the full list of color scales, I think I sent this out in the last class, but a quick Google search of Plotly color scale should give you the range.
Okay, thank you.
Yeah. Anything else I should touch on here? Cool. So on Thursday's class, we'll do another map option, and we'll also spend some time talking about callbacks. That looks a lot more like a...
Bloody.
Yeah, I was going to say very Halloween themed, isn't it? All right, so we do have some new messages here. David, create a new data set on the fly for that. Let me see what these messages have to say. Oh, David, let me just take a look at yours. I haven't seen it yet. Oh, wow, this is great. Super cool. And you changed the location so that it was Iraq instead of DC.
Yeah, basically just.
Oh, this is great.
Typed in the lat long for Baghdad.
Yeah.
Well, I guess I didn't label it that it's fatalities for a protest. These are the protests this calendar year, and then.
That's great. And it just had the latitude and longitude and the number of fatalities?
Yes, after raising the issue, I couldn't get it work because I typed in longitude twice, and I couldn't figure out why it was all out in the Mediterranean.
That would explain it. Okay, super cool.
And anyways, it's an Applet is an awesome data set for. It's only Africa and a little bit of
All right, well, let's go on to tonight's repository, which I believe I slacked out here in the General tab, which is here, 11 data visualization. So respond with emoji when ready in Jupyter Notebook.
Which one are we opening?
Just open the whole thing. I'm not sure yet. I'm still deciding which one to start with here. Someplace in the code folder, there are 3 to choose from.
By the way,
Yeah.
when I tried to run it locally, this is what I got.
Okay. I don't know what the reason for that would be, Regina. I'm sorry. Two, 3, 4, 5, 6, 7. All right, so we have a lot going on here. Data visualization is a big topic. There's a lot under extra materials for you to take a look at individually. These are notebooks that have been developed by other instructors when they've taught this class in the past. And I think you'll find a lot of things in here that are useful for individual study, like good examples of developing data visualizations. I'm going to keep mine focused on the 3 notebooks that I have developed out myself, Chicago Bike Share, Titanic, and the UFO Timeline. But the basic idea here is, up until now, we've used pandas for a lot of exploratory data analysis, for some simple manipulation and recoding, some summary statistics. But really, when you do any kind of a report or dashboard, what people really want to see is some summary graphics, because they're quick and easy to grasp. You know, if somebody has no background on your data set and they don't want to look at your code, they just quickly want to look at a couple of bar charts and a couple of pie charts, maybe a line chart, and get the fast takeaway of the high-level summary of your data. So that's what you're shooting for with data visualization. Now, dataviz is one of those topics that it's like it's Alice's rabbit hole. You can just keep going down and down, further and further. And I do think that some of the previous notebooks that have been used in the past do that. They show you all the bells and whistles that can be used with dataviz. What I'm going to try and do is show you a lot of high-level examples, and then as you want to get more kind of fine grain into the details of a particular graphic, that's the sort of thing that I think is more appropriate for self-study. So we're going to go ahead and get started here with UFO timeline is a good one to start with, because this will give us a number of things that will get us into an example that you can try on your own. So we'll get started with that. This is the UFO data set, and it allows us to build out a simple line chart. So we've got the solution notebook here, and then I'm also going to do a blank notebook. And if I didn't say this earlier, pardon me if I'm repeating myself, I'm spending 2 nights on data visualization because I do think it's such an important topic to grasp. So we'll work on this tonight, and then we'll also work on it again Thursday night. But this one is going to be called UFO Class Notes. And we're not going to be using Plotly Dash. We're going to be using the grandfather of dataviz products in Python, which is called matplotlib. And its first cousin, Seaborn. These are static, they're not dynamic, they allow no user interactivity, but they are very frequently used in exploratory data analysis. So you'll see them in other people's code, and it's a good idea to get familiar with them yourself. Okay, so this is how to build a line chart using time series data. It's kind of the overall topic for this notebook. Import pandas as PD. Put this on big screen and zoom in a little bit. As usual, from pathlib, import path, and import OS, and import NumPy. These are kind of the basic 4 that you'll almost always use. But here are some new visualization libraries that we can import. So import matplotlib.pyplot as plt, import Seaborn as SNS. And then, because we're using Jupyter Notebook, we want to display our results in the notebook itself. So we're going to add this additional Jupyter code. Jupyter settings that start with the percentage sign. Matplotlib inline will allow us to display our graphics in the notebook. If we didn't do this, then they would pop up in Chrome, but that's not actually what we want. And again, these are 2 libraries, matplotlib and Seaborn. They're very similar. Seaborn actually uses matplotlib on the back end, but it has a wider variety of colors and styles. But they are sort of the basic go-to graphic libraries for any pandas work. So let's read in the data. Path to data is going to be equal to path.joinPath current working directory .parent. So we'll go up 1 level. Data, and then UFO.CSV. And UFO is the name of our data frame, is pd.read CSV path to data and UFO.head. Pause there for a minute while you catch up.
So, Wilson, sorry.
Yeah.
Question. So what's the best way to follow along when you get the most out of this? Is to have the solution in like a side or like a 2-column, like a different notebook and refer to it, or just like kind of tag along with you?
I mean, the best way to do it is to have 2 machines, the way I'm doing right now, so you can see the solution on one side and the code on the other. If that's not possible, what I did when I was a student taking this class was that I definitely had the solution code on one side and my own personal code on the other so that I could follow along. And I would recommend you give that a try. Unfortunately, it's kind of like driving through a periscope because there's not a whole lot of screen space. And then the third is if you are able to keep an eye on the screen, some people find that works as well. But by all means, and this goes for everybody, stop me if I'm going too fast. If you need to go back and see code, please don't hesitate to tell me to go back up. And by the way, with regard to cell 3, I hope everybody understands why I keep doing this, because this is not the easy way to read in data. And with most other data science instructors, what you will see is simply this. You'll see UFO is equal to pd.read CSV ... data UFO.CSV. And this works just fine. There's a reason why I do version 1 instead of version 2, even though it's a lot more code. And I'm trying to do it every class so that it becomes familiar to you. But as a good data scientist, one of the most important steps is to be able to quickly and efficiently read in data. And in a classroom setting, somebody's always going to give you a nice file path to where it's located. But in a real world setting, you're going to have to go hunt that down somewhere on your company's server or on the web or just wherever the heck you saved it on your laptop. And being able to use the path library and the OS library, those are really important skills for that initial step of reading in your data, which is why I keep doing it every time. But that being said, if you just go ahead and use the shorthand version, there's certainly no shame in doing it that way. So we have this data set of UFOs that we've seen in the past. And one of the nice things about it is that it has a timestamp over on the right-hand side. So let's check that out. We're going to check out the time variable. And the first thing that we'll want to do is we'll want to describe it. And we see that it's got a number of unique. It's got a very frequent one that happens to be on July 4th. And the frequency of that is 45 different people saw UFOs on the 4th of July 2014. But also we'd like to know what data type is this column. So UFO time, time dot dtype, and it's type object, which means it's coded in as a string. And this actually is not helpful because we don't want it to be a string. We want it to be a date-time variable. And it looks like a date-time variable. It's got month, day, year, it's got hour, it's got minute. But for whatever reason, at some previous iteration of this data set, it was hard-coded as a string. So we need to reverse that. We need to bring it back to its time variable so that we can turn it into a line chart. So we're going to convert from string to date-time format. And this only works if it already has the month/day/year format. You can't convert any string to a date-time for obvious reasons. So we're going to create a new variable, UFO. We're going to call this new time. We're going to set it equal to pandas to date-time parentheses UFO time. And then we'll print UFO new time dot dtype in order to confirm that it is in fact a date time. It takes a little while. It's got to get through about 80,000 rows. But we see that the D type on our new variable is now date time 64, whereas previously it was O for object. And if we do a quick head, check out the comparison, just to make sure that worked, we can call UFO time new time dot head. And we see that the old time and the new time have the same information, but they're displayed slightly differently. Pandas accurately interpreted the fact that 6/1/1930 corresponded to 1930-06-01. All of that was wrapped up here in the PD.toDateTime method, which is really good at parsing strings into dates. Obviously, if you were to have tried that on something else like color, you would not have had a successful response. Well, now that we have it as a date-time format, we can create some new variables. Variables. So the first one we're going to create is going to be one called the date. We're going to set this equal to the new variable that we just created, new time, dot dt for date time dot date, and then call UFO dot head. And we see over here we've got a new variable that simply has the date without the hour of the day. Let's create a few more. This is what's really cool about date time in Pandas, is that you can do a whole slew of feature engineering straight out of the box with one column. So UFO year is going to be equal to UFO new time dot date time dot year, UFO.head. Oops. And now we've got 1930. So we're just creating variables here. We're going to create even more variables. Month is equal to, and I'm just going to copy the same code over here, paste it in, but instead of year, I'll call in month. What did I screw up?
Just 2 equal signs.
Yes, that's exactly what it is. Thank you, Regina. So now the month is from 1 until 12. Let's do a few more. Instead of year and month, we can also do day. Right, 1 through 31, so it's the day of the month. So if you wanted to see, are UFOs more likely to be at the beginning or the end of the month, for example? Let's go ahead and create hour. So are they more likely to happen in the morning or at night? And finally, are they more likely to happen on a Thursday or a Saturday? We get 0 through 6. And you can also break it down to the minute, the second, and I think it also has seasons, if I'm not mistaken, though I'd have to go back and research that. So it can really cluster date time by almost any normal time clustering that you would expect. This also allows you to do date-time math as follows. Let's create a new variable. You could create a variable. Let's just go ahead and use the what's the extent from the first to the last UFO? And we can do UFO new time dot max, right? There's the greatest. Dot min. There's the second one, and we can print these so that they come out together. Print. Print. And then we can do print difference, comma, and we can simply do max minus min. Max minus UFO min will show us that about 3,000 days have passed since the first to the last UFO sighting. And obviously, if you were to apply some filters in there, you could get more, any other difference. But date-time math, that can be kind of nice. And if you wanted to, and I don't have the code in front of me, but you could work up some sort of variable that would show the difference between, this UFO sighting versus that UFO sighting in the number of days or years, etc. I'm pretty sure, actually, if we just drop in the year variable, it will do it for us as well. It'll show us the same thing in years, but not in days. Yep, sure enough, 84 years from the first to the last UFO sighting. All right, and let's create a weekday variable using the dot map method. UFO weekday name is going to be equal to UFO weekday that we created earlier, dot map. And here we're going to map this to 0, goes to Sunday, Monday, Tuesday. Thursday. This is so that we can display it in a minute in a graphic. What we got here? Wednesday. Oh, I forgot that. That's what it is. Okay. Saturday, Sunday, etc. Okay, so which dates have the most frequent sightings? So we can do UFO date that were created earlier and set this equal to value counts, and then take the top of those, and currently ascending is from least to greatest. So we'd like it to be greatest to least. We set ascending equal to false. And we see that the top 5 days for most frequent sightings, 4 of them all happen to be the 4th of July. Curious. One of them happened to be in November for who knows what reason.
There were lights in the sky.
Lights in the sky?
Must be some amazing fireworks.
Yeah. And maybe one too many attempts of raising the wrist. Okay, so to create a line chart, we want a counter column. That is to say, we want to create a data set that will count the number of times this happened per day. So the first thing we do is we create a new column called sightings, and we set it equal to 1. And then you call UFO.head. And if you look over here at sightings, it's simply 1 for everything. Every time somebody saw a UFO, that gets a count of 1. So in and of itself, it's sort of a meaningless column, but we're going to aggregate around it in order to start adding up by dates. Now, add a group by statement, a cluster of data around dates. So we're going to create a group by statement, UFO group by. Remember, you always group by a categorical, you group on a numeric. We're going to group on the date variable, and the thing that we want to group is the sightings, which was all 1s before. We're going to create a sum. So now we see back in the 1930s, most of the time it was just, one night, one UFO. But as you get later on into 2014, etc., you start seeing a lot of days when there were multiple UFO sightings per day. We take this new group by result and we set it equal to a new data frame, which I'm going to call dates df. And now drop the sightings variable. It's not needed. We no longer need this now that we've created the group by, so we can do dates df.drop. Don't forget that whenever you drop something, you have to set axis equal to 1. And then dates df will sort this from greatest to least. And let's take a look at the top 5.
DF is a data frame.
Yeah, I may not even need this. You're right, it is just a pandas series currently, that's why. What am I going to do with this later on? So I'm going to turn it into a data frame. So you don't even need this. I guess that was just like house cleaning. And you're right, it is not yet a data frame, so we're going to convert it into a data frame. Convert to a data frame. So it was previously a series. Now I'm going to call datesDF is equal to pd.dataframe datesDF and also reset its index. Again, this is mostly just for cosmetic purposes. And here we go. Here's where I want to sort its values. By sightings. There we go. Sorry, that was a lot of stuff in a short period of time. But the basic idea here is that I convert it into a data frame using the pd.dataframe method. I reset the index because if I don't, I'll end up with 2 index columns. Which in fact did happen here. I didn't anticipate that reset index. What happens if I don't do that? That's funny. Didn't even need that. So now I've got a date column and I've got the number of sightings. And what this does for me is for any given day, it tells me the number of times a UFO was seen on that day. And here we have the top 5. Now let's merge that back into the original data frame. So I'm going to create a new data set called UFO2, and I'm going to use pd.merge. This is a new method. I'm going to merge 2 data frames using the pandas.merge method. The original one, UFO, and the second one, datesDF. And I want to merge them on their shared column, which is date, and how is equal to left, that is to say only keep values from the original data frame. Let's go ahead and show UFO2.head. Now I've got 2 sightings. This is why I dropped sightings earlier, that's why. If I go back up to the cell and I bring that back, there we go. So what I'm going for is for any one of these, I will now have a there we go. I'll now have a column called sightings that shows for any date the number of UFOs that were viewed on that particular day. And the reason I ended up with 2 sightings variables is because I didn't drop it back here in cell 54. If you drop it from one, then it will only keep it from the other.
So
UFO is equal to, there we go, that's what it is, I'm missing this. Yeah, and now I only have 1 sightings variable, that's what I was getting at. And this now imitates exactly what's in the solutions notebook. Yeah, go ahead, Regina, sorry.
the merge how equals left, what does that mean again?
Yeah, so in the merge statement, I want to merge 2 data frames, the original UFO data frame, and the second one called datesDF that I created afterwards. The column that they both share is called date, so that's what I'm merging on. I'm connecting them because they have a shared date. But how equals left means only keep data from the left-hand data frame, which is UFO. UFO is left, and dates DF is right.
Does
So
that mean it's copying data from dates DF into UFO?
exactly, but not vice versa. If I did not have this, if I had it set to all, or I simply deleted it altogether, then I would have a very large data frame because it would have all of the UFOs and all of the dates, and it would merge information in both directions. So by specifying left, I indicate that UFO is the primary data set, and that's the one where I want to keep the data from, and everything is getting merged into it. So at this point, we have a new data set called UFO2, and this has information that will allow me to build some line charts, which is where all of this has been leading up to, right, is to create some visualizations. Create some line charts from all this. So first let's do trend over years. And here we're going to use Seaborn. We earlier imported Seaborn as SNS, so you don't have to repeat it now. I'm just bringing it back as a reminder. And we can do Seaborn. And by the way, just as an aside, I actually don't know why Seaborn is abbreviated as SNS. I'm sure there's a good reason. I would have expected it to be SB or something like that, but it's not.
Can't you just abbreviate it however you want?
You can, but that's not a good idea because you'll often end up sharing code with other people, either in your team or through GitHub. And because it's sort of industry standard to use certain abbreviations, you kind of want to keep those because otherwise people will wonder why you chose what you chose. If anybody wants to do a quick Google on why Seaborn is SNS, that actually would be an interesting question that I have not answered over the years. But we're going to create a line plot. And here the Seaborn syntax is quite simple. You simply provide it an X variable and a Y variable. Our X variable is the year, and our Y variable is the sightings variable. And the data is the data frame called UFO2. And it takes a minute. And now we have this line plot showing everything from 1940 all the way to 2000 in a nice sort of square output. It also always gives this matplotlib code at the top. It gives it a specific name. If you find that distracting, you can get rid of it by simply adding a semicolon at the end of your Seaborn code. And now it will rerun, but without that additional line of output. And if you'd like it to be a little bit wider, you can set the size by setting the RC parameter to figure.figsize is a dictionary, and we'd like it to be 18 by 6 pixels, fits pretty nicely in a typical monitor. And here we see a nice wide line plot from the 1930s all the way to the late 2000s, showing that the number of UFOs visiting our planet has definitely increased in the last decade for reasons that are pretty easy to guess. Now, this is not Plotly, so it's not interactive. If you hover over it, it does nothing. It's basically a JPEG or a PNG.
What's the shade area behind the line? It's only in there in certain sections.
That's an excellent question. I believe that the shade area is the variability around the mean. What it's showing you is this is the average number of sightings, so it's been smoothed out, but that tends to fluctuate a lot from one day to the next. So to create a cleaner line, it gives the shading.
This is just the count, isn't it?
Yeah, this is just the count.
Or this is an average.
No, it is a count, but also because it's zoomed in so many years, rather than giving an extremely squiggly line, it smooths out the line and provides that shading. Because obviously it fluctuates on an almost daily basis, so you would see a lot of jitter without that. So that's the trend over years. Sorry, go ahead.
Sorry, I guess I'm just a little confused about what like I said, Y is specified as sightings, and X is specified as year. So how is it determined what the aggregation is?
Are you also referring to the blur area around the line?
No, I'm asking what does it mean that there are about 25 sightings in 1999 on this chart?
I see what you're getting at.
What is the aggregate?
Right, because in fact there were a lot more than 25 sightings in that year.
Or is it?
That's an excellent question. I hadn't actually thought about this. I believe that means that the daily average in 1999 was 25, as opposed to the total number of sightings, which would have been a lot more.
Okay.
And we can quickly test that. And again, I hadn't really thought about this. I spent more time generating the graphics than I did thinking about the information in them. But if we do UFO is equal to UFO year, or actually no, not without an equal sign. Let's use a bracket. I'm filtering down to 1999 dot sightings. I'm sorry, it's UFO 2, by the way. I have two of these going on now. Dot mean. Yeah, so it's actually 24 is the average in 1999. Whereas if we were to do the count, that would give the total number in the entire year, which is well over 2,000.
Okay.
So what this means is that Seaborn is taking the average rather than the total count, and that's what it's displaying.
And the shading is like a standard deviation or something.
Then that would definitely be the standard deviation on either side of the mean, yes. And I actually had not thought about that, but that's exactly what it's doing. And I'm going to put a comment in here. Clearly, Seaborn is displaying the mean per year. Why is it doing that?
Okay, it wasn't set anywhere, right? But just does that automatically?
So a lot of Python libraries are what's known as opinionated, which means that they will choose the defaults for you. And if you want to change them, you have to go under the hood and fix them. Yeah.
Okay.
Let me give you a few, again, this is actually new territory for me as well. I hadn't thought about it in this level of detail, so I really appreciate the questions. Let me give you a few more examples, and maybe this will actually become more clear as we look at a few other ways that Seaborn handles this data. So the next one would be trend over months, not years. So we'll do the same thing, Seaborn line plot, but this time X is going to be equal to months, and Y is going to be equal to sightings, and once again the data is going to be equal to UFO 2, and we put a semicolon at the end so we don't get the name of the figure as it's generated. Sightings is not capitalized. And here we see that the average peaks a lot in July and drops back down to a low point in February. So aliens don't visit us very much in February, but they do like coming during July. And I think that, and again, I'm thinking on the fly here, but what this demonstrates is because it's giving us an average and not a count, it's able to slice and dice by a lot of different date time methods. So we saw the year average earlier, now we see the month average, and we can also see the weekday average, weekday trend, exactly the same code, only the X will now be weekday. And at a guess, I'm going to guess that aliens come a lot more on Fridays and Saturdays. And that, in fact, is the case. Again, with the standard deviation on either side of that average line. So let's try multiple lines on same plot. And in order to do this, first we need to create some new columns for specific colors. And for this, we're going to use the recoding method that I introduced in the last class called npwhere, or numpy-where. Remember that earlier we chose to import numpy as np, so we're going to use a numpy method called npwhere. Let's go ahead and first check out our colors. Colors reported value counts head. So orange, red, green, and blue are the most popular colors. Let's create lines for that. For this, we need to create new color variables. So UFO orange, which is the most frequent, is going to be equal to npwhere UFO colors reported is equal to all caps orange. And when that's true, give it a 1, otherwise a 0. And then we're going to do this for the other ones as well. Let's do red is equal to red, and green is equal to green, and let's do other color. Oops. Other is going to be equal to, and here's a slightly different npwhere. So look at how we code this. UFO orange plus UFO red plus UFO green is equal to 0. If that condition is true, recode as a 1, otherwise 0. And now go ahead and call UFO.head. And on the far right, we see that we've got orange, red, green columns and other. And that corresponds to the original color column, a lot of which was actually missing data, which is by far the most frequent. The next step is to collapse the data frame on color and date. So once again, we create a citing variable, which we set equal to 1, so that we can do some counts. And then we create a group by statement, UFO.groupBy. And we're going to group this time by year and also by here. I think I may have earlier created a color variable. Just a second. Oh, that's what it is. Okay, I'm sorry. This cell 73 is actually one that I should have bypassed. This was an alternative. not unuseful in its way, but actually not useful for collapsing. So, sorry, one other way to group by color. Another way to group by color, not using NP-where, is to simply shorten the categories as follows. So we create a new variable called color. We set it equal to other, which is the most frequent. And then we recode it using the .loc method. So UFO colors reported is going to be equal to orange. And then we call the newly created color column, and we set this equal to orange. And then we're going to do the same thing for the other 3 colors. So here we'll reset red to red and green to green. Go ahead and run that. And now down here I can group by the newly created color variable, which I didn't have before. That's the step that was missing. Apologies on that. So that's the categorical variables we're grouping by. The thing we're grouping on is the sighting variable. And this time we want the sum, that is to say the number of sightings by each color. Go ahead and take a look at what dates looks like. And we can see that dates has the year, and for every year, the number of colors that were sighted in that year. All dates.head to keep it short. Now that we've created dates, we want to convert that into a data frame. So this time we're going to call this colors df. It's going to be equal to a pandas data frame of dates. We're going to reset the index. And now we can go ahead and plot this as a line chart. So SNS dot line plot, where x is equal to year, y is equal to sighting, and hue is equal to color of those 3 colors we defined, and the data is going to be equal to our new data frame colors df. Put a semicolon to avoid the code output. And here we see that the other variable has gone up by quite a lot, and the other 3 are quite small. They're fairly infrequent. Because this is tough to read, let's restrict our window of time, and we'll get a more readable chart. Colors 2 is equal to colors df, and we're going to restrict this to the following. Colors df, year is greater than 2000, and in addition, let's get rid of that other column. Colors df color is not equal to other. And then we'll use exactly the same code as we did before, only we'll use the colors 2 data frame. And this is a lot more readable. Here we can see that since the year 2000, the actual color of the lines does not correspond to the colors of the UFOs. And that's something we could fix, but we're not going to worry with it right now. It looks like green has always been infrequent. It used to be that orange was infrequent, but it's actually become the most frequent color to see by 2013. And red, which here is colored as green, is kind of the mid-level line. So let me stop there. I would like to keep going, but I do want to turn some time over to you guys to actually try this on your own. If you look in the data folder, you'll see that there is a file called dataviz 2015-07. And this has time series data that will allow you to create a fairly similar line chart, similar to what I did here. So for about 20 minutes, I'd like you to try and see if you can put that together using, again, this dataviz 2015-07. Let me slack that one out. In general, use this. I'm going to display the code that I used for the UFO dataset on the screen, and I'd like you to try and take the same steps to put together a time series line chart and then slack that out. See if you can do that in 20 minutes. There is some starter code called Chicago Bike Share that you can use to get started on this. That'll walk you through how to create a few categories and then to convert date to date time. So use that if you like. I am going to put the UFO data summary up on the screen so you can also refer to that as your secondary screen. And this is a summary of what we just did in class. And by all means, call me over if you're unclear about anything that's up here, okay? This is going to be So yeah, definitely call me over if anything needs a little bit of review or one-on-one.